So, what if we could borrow genetic superpowers from the distant past to secure our future food supply? I know, it sounds a little like science fiction, but it's actually happening right now. Today, we're going to dive into a pretty revolutionary technique that's making our most vital crops a whole lot safer. Okay, let's get into it. We're talking about hacking the harvest.
Think about this for a second. 1 out of every 5 calories that humanity consumes comes from wheat. That's huge. Now, what if that entire foundation of our global food system was suddenly at risk? The threat here isn't just, a patch of bad weather or some new pest. It's a vulnerability that's buried deep inside the very DNA of the plant itself.
You see, for decades, we've been breeding wheat to be this high-performing champion of yield. And that's created these vast, beautiful fields of what are essentially identical clones. But that uniformity, well, it's a double-edged sword. It's kind of like having an army where every single soldier has the exact same weakness. One new disease, one single new threat, and that whole army could just collapse. And that, right there, is the dangerous genetic bottleneck that we're now facing. So let's take a closer look at this wheat weakness, because this isn't just some abstract problem for farmers or scientists. Nope, this is a global challenge that has a direct line to the food on your plate, and it really affects every single one of us. This uniformity creates what is basically a perfect storm of vulnerabilities. Because there's so little genetic variation, a single new fungus can spread like wildfire through millions of acres. A sudden heat wave or a drought can absolutely decimate a region's harvest because none of the plants have the diverse genetic tools they need to cope. And make it worse of all, after decades of incredible gains, we're starting to hit a wall, genetically speaking. Our ability to keep pushing for higher and higher yields is starting to stall out. So, if our modern wheat is in trouble, where do we find the genetic diversity that we so desperately need? Well, the answer lies in its wild ancestors, these tough, scrappy plants that have been battling diseases and extreme weather for literally thousands of years. It's time for a wild genetic rescue. And the technique is called alien introgression. And yes, I know, it sounds like it's straight out of a movie, but instead of aliens from space, we're talking about alien genes from different but related plant species. Scientists are essentially becoming genetic time travelers, reaching back into wheat's evolutionary past to borrow the very code that will save its future. And this map gives you a sense of just how huge that genetic library really is. I mean, these aren't some pampered farm crops. These are battle-hardened survivors that have evolved for millennia to perfect their defenses. Their DNA is an absolute goldmine of traits that our modern uniform crops have totally lost. So, what kind of superpowers are we actually talking about here? Well, we're borrowing genes that act like a natural, built-in shield against devastating diseases. We're finding genes that allow plants to not just survive, but thrive in a hotter, drier world. And we're even discovering genes that can make our food more nutritious by packing it with essential minerals, like iron and zinc. Pretty cool, right? But how do scientists actually perform this genetic heist? I mean, it's not as simple as just crossing two plants in a field. Nature has its own security system, a really powerful genetic firewall that's designed to keep species separate. So to get those good genes in, you first have to figure out how to hack it. And believe it or not, this entire security system pretty much comes down to one incredibly powerful gene called PH1. You can think of it as a super strict genetic gatekeeper. Its whole job is to maintain order, making sure that wheat chromosomes only pair up with other wheat chromosomes. And that's an essential function for sure, but it's also the single biggest barrier to our rescue mission. So here's the playbook scientists use to outsmart that gatekeeper. First, they make the initial cross. The embryos that result are often super fragile, so they're carefully rescued and then nurtured in a lab. Then comes the brilliant part, the hack. They use a special mutant wheat that's actually missing the PH1 gene. This effectively disables the firewall, and that opens the door for the alien and the wheat chromosomes to finally mingle and swap their genetic material. And this is where the magic becomes visible. Using a technique called GISH, scientists can literally paint the alien chromosomes with a fluorescent dye. So when they look under a microscope, they get this stunning confirmation. Glowing segments of wild DNA now permanently a part of the wheat chromosome. It's like a high-tech game of genetic I Spy, and it's proof that the heist was a success. But Like any cutting-edge science, the path from the lab to the farmer's field is paved with both incredible triumphs and some pretty formidable challenges. This isn't just an easy fix, it's a really complex puzzle. One of the biggest victories so far is something called the 1BLRS translocation. Now, translocation is just a fancy word for moving a piece of a chromosome from one species to another. In this case, a chunk of a Y chromosome that was packed with an entire arsenal of disease resistance genes was successfully moved into wheat. The result? A kind of super wheat that has been a massive success, planted on millions of acres all around the world. But, and there's always a but, right? Here's the catch. When you move a piece of a chromosome, it's a bit like grabbing a file you need out of a filing cabinet, but you accidentally grab all the other files that are clipped to it. That's what scientists call linkage drag. You might get that amazing disease resistance you wanted, but it could come linked to a gene that makes the dough weak and sticky, which, as you can imagine, is a total nightmare for any baker. And yet, despite that challenge, the results really do speak for themselves. This data shows exactly what happens when you compare these new lines to standard wheat. Time and time again, the Introgress lines show dramatically lower infection rates from major diseases. The prize of a healthier, more resilient crop is clearly worth the effort. So, what's next for this incredible technology? Well, we are standing on the cusp of a brand new era. One where this entire process is becoming faster, more precise, and more powerful than we ever imagined. The modern toolkit is a total game changer. Scientists can now scan the DNA of thousands of plants at once, pinpointing the exact location of the genes they need. They can even physically sort individual chromosomes. You combine that with something called speed breeding, which cuts development time from years down to months, and they can now make smaller, much more surgical transfers, grabbing only the superhero gene they want and leaving all that negative linkage drag behind. And all of this leads to the ultimate goal. See, this isn't just about creating a few one-off fixes. It's about building a permanent genetic bridge from that vast wild gene pool directly into our elite crops. By creating a constant flow of diversity, we can help ensure our food supply is dynamic and resilient and that we never, ever face a dangerous genetic bottleneck again. This technology is already giving us a glimpse of a more resilient food future, but it really makes you wonder. With the power to tap into nature's entire genetic library, what else could we do? Could we design wheat that thrives in salty coastal soils? Or maybe rice that's naturally packed with vitamins? The possibilities are just as endless as the wild gene pool itself. What do you think? What should we design next?